How to determine if a triangle can exist given three sides. Physically, you can talk about having a length that's given to you, and then you're trying to bridge together the other two sides to form a triangle. Physically, it's possible that your sides, you call them the legs or whatever, aren't long enough to actually form a triangle. So these would flop down. I could never form a triangle. Or they could have the length that's needed to form a triangle. The way we would determine this algebraically or mathematically, we can take any two sides, add them and subtract them, and look at those results. If the third side falls in that interval, then it would be a triangle, or possibly could make a triangle. Example of what I'm referring to. Example 1. I'm going to start with these two smaller sides. I like to always work just like the Pythagorean theorem, leg, leg, hypotenuse. I leave my longest value out of the process. And so when I look at example 1 here where it says 4, 7, 10, I'm going to take the two so-called legs, I will subtract them. Now I'll subtract larger minus smaller. So 7 minus 4 gives me a value of 3. And 4 plus 7, see I'm adding this time, 4 plus 7 gives me 11. Now the way I write this, I'm going to use something called interval notation. I need the third side to fall within this. It can't be 3, it can't be 11. Because in that situation, when we talk about this geometrically, what you'd be looking at is, if this is my third side, I would have one leg that goes here and the other leg that goes here. Well, that wouldn't form a triangle because it's just covering the length of that third side. It has to be something that actually falls within there. Okay? So when I look at the 10, does 10 fall between 3 and 11? And the answer, of course, is yes. Since 10 falls between 3 and 11, we have a triangle. This means therefore a triangle exists. Now I've got a couple quick examples because the math here really is not that difficult. So I'm going to go to example number 2. Once again, I'm looking at these smaller values, the legs, the so-called legs of my triangle. I'm going to subtract them, then I'm going to add them, and see if the third value falls in that range of numbers. So when I subtract this, 9 take away 5 is 4. Tells me I need a third side that's at least 4. It has to be a little bit bigger than 4 to make a triangle. And then when I add this, 5 plus 9 is 14. I have to ask myself, does 17 fall somewhere between 4 and 14? And it does not. 17 is larger than that group of values. You can almost think of it like when we were doing inequalities. You've got 4, you've got 14. You're looking for something that falls in that shaded region. And 17 doesn't fall in there. So you would say this is not a triangle. So therefore there is no triangle. And we'll do a third example. As we do this third example, I've given 6, 7, and 12. Process never changes. I look at the two smaller values that are given. I start by subtracting the smaller from the larger of the two values. So 7 take away 6 is 1. And 6 plus 7 is 13. Now technically the way I'm drawing this interval notation, these circles, if we were to graph this, would actually be colored in. But because it's a new notation, I didn't really want to get into all of that. We're going to leave them as open circles because you can't really have this value. We don't want that third value to be 1. And I shade to 13. And I'm simply asking myself, does 12 fall in this interval? Does 12 fall in this shaded region? In this case, it does, which means that I can make a triangle out of the sides 6, 7, and 12. And so you say, therefore, a triangle exists. And that is how you can determine the existence of a triangle. The existence of a triangle. You take the two smaller sides, i.e. the legs, you subtract them, you add them. If the third side falls in that interval of values, then you have a triangle. If it does not fall in that interval of values, you do not have a triangle. So there's your examples on the existence of a triangle.